This is Algebra 1, Lesson 9.4, LCM and GCF of monomials. Just as a reminder, what is a GCF? GCF stands for the greatest common factor. And if you have two numbers, it's the largest number that is a factor of both. That means what number goes evenly into both of them. And you can find the GCF for two or more monomials by finding the product of their common prime numbers or factors. So I'll show you a couple different ways to do it, and you can use your favorite. Let's try an example. We're looking for the GCF, the greatest common factor, the biggest number that goes into both of these evenly. One thing you can do is just start listing the factors, the numbers that go into 16 evenly. Just like when we were factoring quadratics, we said, hey, 1 times 16, 2 times 8, 3 doesn't go into 16, and 4 times 4. And once you repeat, that means you're done. So let's do it with 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into it evenly, and then 5 times 6, and we're back to 6. So these are all the numbers that go into 16 evenly and into 30 evenly. So we're looking for the greatest, the biggest one that they have in common. Let's see, what's that going to be? Looks like it's going to be 2. It looks like it's going to be 2 is the biggest number. So our GCF of 16 and 34 is going to be 2. That's the largest number that they have in common. Now we want to look at their exponents, and we want to take just what they have in common. They each have 1x, so we can take out 1x. This one has 2 y's, this one has 1 y, so we're only allowed to take 1 y out. So that would be our GCF. Okay, let me show you a different way you can do it, and again, you can use whatever you like best. One way you could do it is do your prime factorization. We're going to do a factor tree of 16. So we can say that's 2 times 8, 2 times 4, and 2 times 2. So this is 2 times 2 times 2 times 2, 4 2's. 30, how about 3 times 10, and 2 times 5. So it's 2 times 3 times 5, and we're going to use just what they have in common, and you can see they only have 1 2 in common. That's where we got our 2. And then this one has 1x and 2 y's, and this one has 1x and 1 y, and only what they have in common. They both have 1x and they both have 1 y. Okay, so whatever you think's easier. Okay, it doesn't have to just be 2 monomials, it could be 3. So we have a 10, a 15, and a 25. If I break down my 10, it's 2 times 5. If I break down my 15, it's 3 times 5. And if I break down my 25, it's 5 times 5. So you can see the only thing they all have in common is 5, so that's our greatest common factor. And then again, we can only take what variables they all have. This one has 2m's, 2m's, 3m's, so we can take 2m's. This has 1n, 2n's, 1n, so we can only take 1n, just what they have in common. So that's our GCF of these 3 monomials. Now we're going to talk about least common multiple, or LCM for short. The LCM of two numbers is the smallest number that is a multiple of both. Okay? You can find the LCM of two monomials by finding the product of their common prime numbers, just like we did before, but then we have to throw all other prime factors that are not in common. So let's practice it a couple different ways. Again, you choose your favorite. One way is to just start writing the multiples. We're looking for the least common multiple, and the first time we run into one they have in common, that's going to be our answer. So I'm going to say 10 times 1 is 10, 10 times 2 is 20, 30, 40, 50, 60, 70, 80, 90, 100. Hopefully that's enough. Then we're going to start with the 18s. 18 times 1 is 18. 18 times 2 is going to give us 36. 18 times 3 is going to give us 54. 18 times 4 is going to give us 72. 18 times 5 gives us 90, and boom, there we have it. That's the first one. That's the least common multiple, the first multiple they have in common. So for us, it's going to be 90. And this time, we want the larger of the two. So this one has 1x, this has no x's, so we're going to use 1x. This has 2 y's, this has 1 y, so we're going to use the 2 y's, okay? Last time it was only what they have in common, this time it's what's greater of the two. All right, let me show you another way to do that, and you can choose whatever you like to do. The other way, we're going to do that prime factorization of the numbers again. So 18 is 2 times 9, 3 times 3. So we have 2 times 3 times 3. 10 is 2 times 5. So first you take what they have in common, which is 2. So they both have a 2. And then we have to throw everything else in. So this one has 2 3's. And this one has a 5. So 2 times 3 is 6. Times 3 is 18. Times 5 is 90. And boom, there we are. Okay? Now, this one has 1x and 2 y's. And this one has 1 y. So you take what they have in common, which is 1 y, and then you throw everything else in. We also have another x, and we also have another y, so that would be 90xy to the second, or 9y squared. All right, let's try another one. And again, whatever your favorite is, you can start listing the multiples. We have 25 times 1, 25 times 2, 25 times 3, 25 times 4, 75 times 1, 75 times 2, and you can see the least common multiple is 75. If you like the prime factorization, this is 3 times 25, which is 5 times 5. So this is a 3 times 5 times 5. This one is 5 times 5. So what do they have in common? They have 2 5's in common. So we're going to use those 2 5's. And then you have to throw everything else that's left over. So that's 25 times 3, or 75. Same thing we had. This one has 2 n's. This one has 4 n's. So you take what they have in common, which is 2 n's. And then you throw the leftovers in, which is 2 more n's. So this is 75 n to the 4th. All right. Please try the practice problems. Let me know if you have any questions. Thank you.